Welcome to React Boston. How's everyone doing? All right. My name's Dave Ceddia. I'm a kind of a speaker, author, blogger, egghead instructor. This is my third time at React Boston, my first time speaking. Any other third timers out there? Yeah, a few. Cool. I've been using React professionally since around 2015. And when I started writing React components, we wrote them like this. Anyone remember create class? Yeah. And var? Pour one out for var, huh? Where would we be without var? Don't answer that. So it was so cool to be able to write React components. I remember I was using Angular.js. Back then we called it Angular 1. And React was just like such a breath of fresh air. Being able to write everything in one file. It was really nice. It was like clean. And I really feel like React kind of ushered in the component age of front-end development. It's like JSX and one-way data flow, and like all the big frameworks are using components now. We've got Vue, we've got Svelte, Angular, I guess. I mean, React had classes before JavaScript had classes, and then when JavaScript added classes, React adapted. So components started to look like this, and I skipped the bit where we had to write constructors. Now we just have property initializers. We can just initialize state as a property. We can initialize our methods as arrow functions. We don't have to worry about binding this manually. It's great. And all this stuff kind of just came for free with advancements in JavaScript, which is awesome. And React has always been really good about backwards compatibility too. So actually before this talk, I tested out. You can still install an NPM module and create components with create class. Even with React 16.9, it still works. So backwards compatibility has really been like a feature of React all along. And the other thing that classes have always given us is lifecycle methods to hang behaviors off of, like fetching data or subscribing to things. So like here's a component that is a blog post fetching comments related to the blog post. But we've got some duplicated logic here. So we've got to get the comments when the component first mounts. And then we have to keep an eye on the post ID, and if that prop changes, then fetch new comments for the new post. And even though we're kind of bundling all the heavy lifting into one function right here, we've still got to do this manual synchronization work, right? We're sort of manually keeping in sync, like if the post ID changes, then go fetch new comments. And it's kind of hard to reuse. Like basically, you need all of this code every time. If you want to make a new component that fetches comments, you basically have to end up copying and pasting this thing all over your app. So this brings us to October 2018 at ReactConf, when Sophie Alpert and Dan Abramov announced a proposal for React hooks. And I wasn't there, but I had the second best thing. I got to watch the live stream. And then I checked Twitter, which it was actually really positive for Twitter, especially for Twitter. People were really excited, actually. So I think I saw 5 implementations of Redux in the first hour, people declaring Redux is dead. Again, it's not dead. But so I had a thought. I was like, it's Thursday. It's like, I do blogging. I could learn hooks this weekend and write a blog post for Monday. It's like, or I could write 5 blog posts and do one each day. So I did this. I called it Hooks Week. I wrote 5 posts in 5 days. And by the end, I was feeling a bit like this. But I learned a lot. I learned how to write an infinite loop in React. And sidebar, I really thought my CS degree had prepared me for how to, all the different ways you could write infinite loops. And it turns out, no. There are more ways, and we'll talk about one of those later. So today I'm going to give you kind of a guided tour of React hooks. We'll talk about kind of the main 4 or so hooks that are the ones the bread and butter hooks. If you haven't tried them yet, hopefully maybe it'll make you excited to try them out. And if you have been using them a while, maybe you'll pick up something new. So before I go into the hooks, how many people have used hooks so far? Yeah, okay. Hopefully this is all review for you then. Great. How about people who haven't used hooks yet? All right, cool. Awesome. So before I show you the code, I just want to mention that hooks are additive. They are a new feature in React. If you like using classes, you can keep using classes. I mentioned the backwards compatibility earlier. React is really good about that. And classes aren't like disappearing. So keep using classes if you want. And I think if you're in the boat where you're like learning React now, I would recommend learning hooks and classes because I really think there's enough code out there that still uses classes that you're going to run into them. So yeah, so don't throw classes in the trash. But anyway, so let's talk about hooks. So we're going to write a little component that says hello to people, and we will render out how many people we have, and we'll have a button that like welcomes one more. So if we were going to write this with normally, it's like pre-hooks, this is the point where you're writing a function and you're like, oh, I have to turn it into a class. You're like, okay, I guess. So let's do that. Okay, so we'll write class app extends React component. This function is basically like the render function, so we'll just rename it render. We can tab it all in. We can initialize our state. We'll give people, initialize it to 300, maybe. And then we can render out this.state.people. And then we've got to write our onClick handler. So we'll call this.setState, pass in an object, set people to this.state.people plus 1. And it works. Right? This is like bread and butter React. Been able to do this for a while. So let's do the same thing in hooks. So we're going to import the useState hook from React. This is the first one we'll look at. And at the top of the component, we'll call useState, and we'll pass in 300. So each useState invocation gives you an individual piece of state. And so this will be our people. So useState returns an array with 2 items in it. We're going to destructure that array into people and set people. So it's kind of like state and set state. And then we'll render out our paragraph. So we just have a variable called people, and we can just render it out. And in our button, we'll write our onClick handler. And we can just call set people and pass in people plus 1. And this works too. And it's a lot cleaner, right? Like we just have variables now. We don't have to worry about this. Yeah, it's nice. But you might be wondering, like, how does this actually work? If you're new to coding, like you might be thinking like variables have broken. Like, well, how does it remember something? The function ends and the variables are still around somehow. And if you've been programming a while, you might be thinking there's some compiler trickery going on. This was kind of my first guess. Like I was like, maybe okay, React is like pre-compiling it and it's like annotating the class with some state or something. But no. But before I tell you how it actually works, I just want to kind of zoom in on this destructuring bit here, because I think this kind of trips people up if you haven't seen array destructuring before. What this is really doing, it's just returning an array with 2 items in it. And since array elements don't have names, you can give them names when you destructure them. So this is the same thing as like sticking that value into an array and then creating a variable called people and pulling out the first element and set people and pulling out the second element. So that's all that's doing. So let's look at how hooks manage to actually retain state between renders, because this is kind of the magical part, I think. And it's not magic, it's just arrays. So before React calls your component, it creates this backing object, like an array of hooks, and with a bunch of empty slots. And it has an index into that array, which it initializes to the first element. And so when you call useState, that useState call occupies that first slot. So the first slot gets that value 300, and the index moves down. So now, when we call setPeople, that's going to increment the number, and the index resets. And this is crucial, because now when we re-render the component, it can start at the top again, and it can match things up hook by hook with each slot. So now useState, it knows, well, okay, there's already a value in this slot, so instead of initializing it to 300, I'm going to pull out the 301, and that's how we get people, and we increment the index. So let's look at one more example of this, just to kind of drive the point home. This one has 3 pieces of state. We've got a username, a password, and a remember checkbox. And I've named the setter set remember me just to make it clear, like you don't have to call it like x and set x. You can call it whatever you want. That's conventional, but it doesn't really matter. So yeah, so as we change the state here, you can see the state is updating down below. So let's go through the same exercise. So we've got this array. We initialized that index to the first item, and we run this first line. And so we initialize the first slot to an empty string for username, second slot, empty string for password, third slot is false for remember. And now let's say we type a D into the username field. So now we're going to call set username, right? And it's going to update that first slot to a D, and then re-render and reset the index again. So now we match them up again, right? So we pull out the D, put it in username, password is still empty, and remember is still false. So this is how hooks manage to retain state between function calls. And every instance of a component will get its own copy of this array. So if you copy and paste, 10 login forms across the app, they're not going to share state. So this leads to some rules, though. We've got some rules here. The call order has to be stable. Because of this ordering, matching up thing, you can't sometimes run the hook and sometimes not run the hook. So basically, you can't put hooks inside ifs or loops or nested functions or callbacks. It also means you can't do things like do a null check and then create the hooks. Basically, your hook use states and stuff need to be at the top of the function. You can only call them from function components, classes. You can also call them from custom hooks. We'll talk about those in a little while. And when you write custom hooks, the names have to start with use because there's an ESLint rule that checks that these rules are followed. It's built into Create React App, so if you're using a Create React App project, you'll have this for free. And it's super helpful. So it knows to check React components, but it doesn't know to check random functions. So if they start with use, it will check that they're following the rules of hooks. So let's look at the useReducer hook. Your first thought's probably Redux, right? So I'm going to show you a super simple example of useReducer just to kind of show you how the mechanics work. So we'll import useReducer from React, and at the top of the component we'll call useReducer, and we'll pass in 2 arguments. We've got the reducer and the initial state. So it's similar to useState. We've got to pass the initial value. This is going to be like a little room component with a light switch. So we've got true, meaning the light is on. And this is going to return an array with 2 elements again. Same kind of story. We get the value, which we're going to call light, and the setter, which we'll call dispatch. And then I'll paste in some stuff. And then when we click the on button, we'll dispatch the string on, and when we click off, we'll dispatch off. So if you're familiar with Redux and actions and all that good stuff, you might be thinking like, Dave, you're dispatching strings. What about the Flux standard actions? What's going on? So you really don't need to. I think this is kind of a new paradigm, and I think it's likely that reducers will be scoped to a component. And I wouldn't worry so much about making sure your actions follow they have to be an object with a type and everything. If you need to pass more stuff, then by all means do that. But don't feel like you have to. So now we can write this reducer function. So it's going to take the state and the action that we just dispatched, and it'll return a new state. So this dispatch is a little bit like the useState setter, but it has sort of this extra pass-through. It has to go through the reducer. And the reducer gets to decide what that new state's going to be. So we can switch on the action, And if we got that string on, we'll return true. If we got off, we'll return false. And if we didn't know what this was, we'll just return the state alone as it was. We've got our little room now. We can turn the lights on and off. Cool. The other neat thing about useReducer, though, is that since this reducer function doesn't depend on any variables in scope here, we can kind of just cut and paste the whole thing into a new function called lightSwitch. And now we can reuse this across components. You could even put this in a separate file if you wanted. So this makes useReducer pretty powerful. You can use it across multiple components if you've got kind of some reusable logic you want to use. So that kind of leads to the question, like, when should you use reducer versus useState? Because they're pretty similar, right? So I would say useReducer is a good choice when your state depends on other state that's sort of in the same bundle. I think like undo and redo is a good use case for this, where every state update basically depends on the past. It changes the past, the present, and the future. And useReducer is a good fit for that. Or if your update logic is complex, like if you just have a lot of stuff in your update functions, you can move that into a reducer. I think the third one is you feel like it. Like, go with your gut on this one. They're pretty similar. Okay, so let's look at another hook called useContext. How many people have used the context API before? Okay, cool. So I'm going to do like a quick overview of like how context works, because useContext, it's really not very useful without the context API. So, so we've got this app here with a user object, and the user is being displayed in the sidebar and in the header. Right, so we've got to pass this user down to, well, to the header. Header displays it right away, and into the body, which sort of just accepts it and forwards it along to the sidebar. And then the sidebar renders it out. So this works fine, but it's sort of like a minimal example of this like prop drilling, prop threading problem, where you're passing props down through components that don't actually need them. And for one level deep, this is not a big deal. But if your app has, if you're doing this like 7 levels deep or something, it gets kind of painful. So the context API lets you kind of make this thing available to an entire subtree. So we can create a context by calling React.createContext. That'll return an object that has a provider and a consumer, and they're kind of like a matched pair. And so then we can go and wrap some chunk of our app with a provider and pass in a value prop. We'll pass in the user. And so this makes that user available to everything underneath this subtree. So the header, the body, children of both of those, and so on. So now we can go down to our sidebar component where we need the user, and we can wrap this bit in the consumer. And then we'll save, and we'll promptly get this error. Because the consumer it uses the render props pattern, so it expects that its child is going to be a function. So it's going to call that function and pass in the value. So we'll wrap this thing in a function, and that'll fix it. So now we can pull out that value that we passed into the provider earlier. We can call this whatever we want, just in arguments. We'll call it user. And now we don't need the user prop anymore. And we don't need to pass it into sidebar. We don't need to accept it in user, body. We don't need to pass it into the body. And hey, it works. Awesome. So that's the context API in a nutshell. So let's see how useContext makes it a little bit nicer. So one sort of downside with the context API is this sort of having to wrap things with with that consumer. So we'll import the useContext hook from React, and then go down to the sidebar component. And now we can call useContext, and if we pass in the entire context object, not just the consumer, but the whole thing, pass in that object, and we get the value out. And now we have the user, and we don't need any of this messy nesting stuff. Awesome, it just works. So I think for this example, it's pretty small, but you can imagine like if you're component is consuming multiple contexts, that nesting gets deeper and deeper, and it's just messy. So this cleans it up a lot. It's awesome. So you might be wondering, can you replace Redux? Is Redux dead? I mean, you've got context now to make stuff globally available, and you've got reducers. So I would say maybe. It depends. If you have just a few values, pretty simple ones, maybe an auth token or something, context is good. Use context. This is good for like if you have like a global theme setting or the logged in user or some language setting or something like that. A couple things that don't change very often, I think context can be great. If you have a huge bundle of app state, I would stick with Redux. Otherwise, actually use selector because Redux has hooks now, so that's cool. Otherwise, you end up kind of reinventing Redux with context and reducers. And ultimately, you're going to end up rewriting Redux. It won't work as well. It's going to be slower. Just use Redux. OK, so let's look at the next hook called useEffect. And so useEffect is kind of like 3 life cycles in one. This is how we do life cycles in function components. But I would encourage you not to think of it in terms of life cycles, because otherwise you sort of end up doing this mental gymnastics trying to map life cycles to, like, how do I write the effect to do this life cycle? Instead, I think thinking of it in terms of synchronization is better. So let me show you some examples of this. Do kind of a minimal useEffect example. We've got useState and useEffect here. We're going to have a piece of state called title that'll be empty, and we'll have an input that just lets us change this title. We'll type into the input and update the title. So we want to synchronize the title in the box with the title of the page, which now says React app. You can see it in like size 8 font up there. So we can write our useEffect. And useEffect takes a function. And what this does is it kind of queues up the function to run after this render finishes. So like the app component will run, it'll queue up the effect, and then once it's rendered, your effect function will run. So in here we can say document.title equals title. So we'll set the title. And now as we type into the box, the title updates. Cool. This is sort of like component did update, but it's a lot more minimal. So let's look at another example of useEffect. This is Reddit. We're going to fetch some posts from Reddit. So we'll initialize some state called posts to an empty array. And then we'll write our little render thing here that just renders out the list of posts. We'll map over them and render out a list item with the titles. And it's empty so far. So we can call useEffect. Same kind of thing, we'll pass in our function. And we can fetch the posts from Reddit. Cool trick, if you put .json at the end of a Reddit URL, you get JSON, which is neat. And we can parse it as JSON, and then the JSON is actually pretty messy, so we have to do something like that. And then we can take the posts and call setPosts. Cool. So this should work. But before I save this, I'm going to open up the network tab. We'll hit save. And just keep an eye on this. Yeah. So this was like my first experience with useEffect. I was like, oh, cool, I can fetch data. It's like, oh no, I'm taking down Reddit. So the way to solve this is to pass the second argument to useEffect, which is the dependency array. And this is kind of like, this is the tricky part of useEffect, I think, figuring out what to put in this array. But so if we pass empty, it says this effect depends on nothing, which means that it's always going to run when the component mounts, and then no more. So then we only get the one request, which is great. So let's look at, sort of talk about this dependency array a little more, and we'll do an example with 2 inputs. So I'm going to copy and paste this one. We'll make a new, I have to wrap it around. I'll make a new one called number. We'll make a new piece of state called number. And so inside this useEffect, I'm going to log out the title. So when we can see when this effect is running. And so we've got our two inputs. I'll open up the console. And you can see that it's already called setTitle once because useEffect runs on mount. Right? So after the component mounts, basically after every render, right? So like the mount is a render. So we've got our empty title. And as we type into the box, you can see it's running the effect on every key press. And as we type into the number box, we can also see that it's still running the effect, which is setting the title, which is sort of unnecessary, right? Because this effect doesn't care about the number. So we can add this dependency array and say that this effect only depends on title, and now we're synchronizing document title with this piece of title state, but only when title changes. So if we try this again, we can see if we type in the first box, it updates the title. If we type in the second one, it doesn't run the effect. So the way effects run, so we've got the initial render. Right? It's always going to run once, and then it will clean up before it runs again. I'll talk about the cleanup in a second. And then clean up one more at the very end. So it's simpler than the whole life cycle diagram. And I haven't mentioned yet this cleanup feature. So we can return a function from useEffect, and if you're doing some kind of something that needs to be cleaned up, like maybe setting up a timeout, you can clear that thing in the function you return. So, and due to the magic of JavaScript closures, this timer value is latched so that the function you return is going to clear out this specific effect's timer. So if the effect ran multiple times, it'll clear out the right one. So another angle that I think, another way to look at useEffect is to sort of think of it as like if this, then that for your React components. Or maybe more accurately, like when this, then that. If you think of it as this effect will run on every render, and do you want that? Like if not, then when should it run? And that'll sort of influence what you put in that dependency array. What change should cause it to run? So you could think, like for our example earlier, when the post ID changes, then fetch the comments. You can think of the dependency array as kind of a filter. The effect is always going to run, but you can filter it down to only run certain times if you pass in that array. The other way to look at it is every variable, every piece of like props or state or anything you use inside your effect function, you should put inside the array. Just like mechanically copy all those into the array, and you'll be safe. So the last thing I want to look at is custom hooks. So alluded to this earlier. If we have here's a component that shows some spoilers when you click the button. And we can, so the cool thing about hooks is that since they're just function calls, you can like move them around. As long as they're happening inside of a component render cycle, right? Somewhere inside a component, it's fine. So we can like cut this and paste it into a new function called useToggle. It'll take an initial state, render out our initial state, and we can return pretty much the same thing. So we're pretty much just wrapping useState here, right? This is not a big departure. So, but we can use our useToggle hook inside the component, and it's going to work the same way. Apologies if that was news to anyone. So, but this useToggle hook is not very toggly yet. It's pretty much just state, right? So we can change it to actually be kind of more specific for our use case and actually toggle the state on and off. So we'll replace this setVisible thing with a toggle function that we can write right here. And we'll just write a function that calls setVisible to the opposite of visible. And here is another way to call useState. So you can pass in the value, like I've shown earlier, or you can pass in a function. And this function will get the current state, and you can return the new state. This is useful if you want to do a set state without having to depend on some variable, which will be important in a second. But now we've got this toggle function, and we can just call it toggle visible instead, because that's a little more accurate now. And down below where we're, when we click this button, we were previously setting visible to like the opposite of it, right? But now we've got this purpose-built toggle visible function, which is kind of cool. It's a little more intentional, I guess. And it works the same way. But there's one more problem with this, is that, so on line 10, this toggle function is going to be recreated every time the component re-renders, right? So every time you click the button, new toggle function. And for this app, it doesn't really matter. It's fine. But for, if you're making a general purpose custom hook, there's sort of a problem with this. And there's a bit about useState that I haven't mentioned yet, and that's that the setter function that it returns is always the same between every render. So it's like referentially equal. It's the same function every single time. And this matters because if you have like pure components that would re-render if their props change, you can pass in one of these setters, or say the useReducer dispatch function, and that component won't have to re-render. So we'd kind of like our use toggle to follow that same contract, because right now it breaks the contract. It's going to re-render every time. So we can fix that with the use callback hook. And so we can import use callback from React again. And if we wrap this function in use callback, well, like this, it doesn't really do anything different. It works the same way. Use callback just wraps a function and gives you a function that calls that function. So this is no better so far. But use callback also takes a second argument, like useEffect does. So we can say, what does this callback depend on? And we can say, it depends on nothing. Because set visible is never going to change. So effectively nothing. And now our toggle function is only going to be recreated, it's only going to be created once. And so as far as this app is concerned, it's going to work exactly the same. But if you were going to use this hook in something else where that referential equality matters, then this is a little safer to use. So custom hooks are really cool. There's lots of ideas, lots of things out there you could use them for. There's a couple sites that have lists of hooks. This Nick Graph has a sort of a searchable list. You can type in names and stuff, and I think it's like relatively up to date. And there's this awesome React hooks repo, and if you just like Google React custom hooks, you'll find a billion of them. But and there's also more hooks that I haven't talked about in this talk, like we have use memo to memoize expensive computations. We have use callback. We did talk about that one. We've got use ref to create DOM nodes. Refs to DOM nodes. So if you need to like focus an input or measure a DOM node or whatever, use ref is good for that. There's use layout effect, which is like useEffect, but it runs before paint. So if you need to do some state updates and you're getting some weird flickering, switch to use layout effect. That should probably fix that. There's use imperative handle, and there's use debug value, which is lets you label custom hooks in DevTools. So if you want to learn more about hooks, the official docs are a good spot. They're really well written. They've got a really good FAQ about like common concerns and stuff. And they've got API references for all the different hooks. I've got all my hooks week posts and a few more at daveceddia.com/hooks. And just the other day, I saw this awesome Thinking in React Hooks article, which I think was like partially done at the time, but I think it's done now. Amelia Wattenberger has put together this awesome comparison of like life cycles versus effects, and she's got these really cool visualizations and stuff. You can check that out too. So you can find all the slides at daveceddia.com/Boston. And yeah, thanks for listening.